In this video, we are going to solve the projectile motion problem here using kinematic equations. So the first thing that we want to do whenever we're looking at a new problem, we want to read through the problem and we want to try to draw a picture of what is actually happening. So first, I'm just going to read the problem statement. It says, consider an object that is thrown from a ledge. You don't know if the object is initially thrown upward or downward, but you do know that it lands at an angle of 60 degrees below the horizontal on the ground below. The total time of flight is 1.5 seconds, and the total horizontal displacement is 25 meters. Determine the initial launch height and initial velocity in terms of magnitude and direction. Okay, so I've actually drawn two pictures here because I don't know if the object was initially launched upward or downward. So I've drawn one picture where the object was initially launched upward on the left, and one picture where the object was initially launched downward. I do know that the object landed 25 meters away from where it started in the X direction. So I've labeled that on both pictures. So I don't know which picture is right, but whichever one is right, the object lands 25 meters away from the base of the cliff. I also know that the object lands at an angle of 60 degrees below the horizontal. So this is telling me about my final velocity. And so I've drawn in my final velocity vector for each of the two pictures, and I've given the 60-degree angle between my final velocity vector pointing down and the positive X direction. And the sides of this triangle are obviously Vx final and Vy final. So now that I have drawn my picture and put all of the information that I know in, I can write down all of the things that are known in terms of variables. So I'm going to begin by just writing down the things that I know about x. Well, because I'm not given any information about my x starting position, I might as well just say that my initial x position is 0. My final x position is 25 meters in the x positive direction. My initial x velocity is unknown. My final x velocity is going to be v final multiplied by the cosine of 60 degrees. And that's coming from my triangle here. I'm taking the adjacent side of my triangle, and I know that this x final velocity is going to be positive because my object is moving in the positive direction. So I'm going to use a standard coordinate system where to the right is my positive x direction and up is my positive y direction. I also know that my acceleration in the x direction is 0 because my acceleration in the x direction for projectile motion problems is always 0. I can likewise list all of my known y variables. To do this, I need to pick an origin for my y. So I am going to just choose that the ground is the 0 of my y. So I'm going to, on the ground right here, I'm going to say y equals 0. And then I can say y initial is going to be some height h, which I don't know what it is. I'm looking for it. I've just labeled it as h here in my diagram, but I do not know it yet. I know that y final is 0, however, because I end up landing on the ground and I've assigned the ground to be 0. I know Vy initial. I do not know Vy initial, but I do know Vy final, which I can write as the magnitude of V final times the sine of 60 degrees. And again, that just comes from analyzing my V final triangle. And I know that my acceleration in the y direction is negative 9.8 meters per second squared. Additionally, I know that my total time of flight is 1.5 seconds, which is taken from my initial problem statement. Now that we have our picture drawn and all of our known information written down, I just want to remind us of the 6 kinematic equations. There are 3 for x and 3 for y. And our goal, now that we have all of our information, is to look through these equations, compare it to the values that we already know, and see if we can increase the number of variables that we know. Now, if you don't know where to start when doing this, just start at the top and go through the equations one by one, trying to see if you have enough information to solve for any of the variables, right? Eventually, we're trying to find the initial velocity and the height of the cliff, but many times we don't have enough information to solve that immediately, or at least to find all of it immediately. So let's just start at the top here. If we look at my first equation here, Vx final equals Vx initial plus Ax times t. Now, this equation might initially look kind of nice because we know Ax and we know t, right? Ax is known as 0, t is known as 1.5 seconds. The problem is that we don't know Vx initial. And because we don't know Vx initial, we can't find Vx final and vice versa. So there's 2 variables in this equation that we don't know, Vx initial and Vx final. Okay, so that equation didn't work, but undeterred, we will try the next equation. So the next equation that we're going to try is my second kinematic equation. Now, I know that the third term here, this Ax term, is 0 because my acceleration in x is 0. I know time. I don't know Vx initial, but I do know x initial and x final, because at x initial, if I look back at my known variables, x initial is 0 and x final is 25 meters, which means that in the second equation, there is only one variable, Vx initial, that I do not know. So let's take that and solve. So moving over here, I know that x final, right in black here, that x final equals 25 meters equals x initial is 0, plus Vx initial multiplied by 1.5 seconds. These are just values that I am pulling from my list of variables here. X final is 25, x initial is 0, t is 1.5. And notice that I have only one unknown variable here, which I can solve for. That is that Vx initial must be 25 meters divided by 1.5 seconds, which is 16.7 meters per second. So this is very useful because now what I can do is I can use the fact that I know the initial velocity in the x direction to actually find the final velocity in the y direction. And this is a step that we take actually without the kinematic equations, just using trigonometry. So I know that Vx final equals Vx initial. This is just from my first kinematic equation because there's no acceleration in the x direction. Its velocity is constant. And I know the value of that velocity. And from my drawing, I also know that my final velocity makes a 60-degree angle with the horizontal. So I can draw my v final vector and the components of my v final vector like so, where this side is Vx final, and this side is Vy final, and the entire thing is V final vector. And I know that this is a 60-degree angle. And I can actually use trigonometry now to find out Vy final knowing Vx final. So I know that if I write tangent of 60 degrees, that is the opposite over the adjacent. So that is going to be Vy final divided by Vx final. So Vy final equals Vx final multiplied by the tangent of 60 degrees, which turns out to be 29 or 28.9 meters per second. And because this points down, I'm going to put a minus sign here. So my calculator, when I just put it in, gave me a positive, but I can see that my V final vector is pointing in the negative y direction, because remember I assigned back here my coordinate system to be up is the positive y direction, and clearly my final velocity is in the negative y direction. So now I have been able to find my Vy final, and now I can use that in order to find out about my Vy initial. So now let's go back to my kinematic equations. I'm going to add in to my known values here the value of Vy final, which is equal to negative 28.9 meters per second. And with this additional known value, I can look at my kinematic equations specifically. And again, if you're doing this on your own and you don't know where to go, just try each equation until you find one that you can solve, right? Here, I know where I need to go. I need to go here because I know time, I know AY, and now I know Vy final, which means the only thing I don't know is my initial y velocity from this equation, which means I can solve for my initial y velocity. So let's go over and solve this equation. I know that Vy final equals Vy initial plus AYT. This is negative 28.9 meters per second equals Vy initial minus 9.8 meters per second times t, which gives Vy initial as 14.2 meters per second. So now I can go back up and add this to my list of known variables. Vy initial, no longer unknown. It is in fact negative 14.2 meters per second. And knowing this, we now know all of the components of Vy final, of Vy initial, so we can actually draw out this vector and find its magnitude and direction. So I know that if I want to draw this vector, I need to go in the x direction a value of, let me go back and check. There it is, 16.7 meters per second. So I am 16.7 meters per second in the x direction. I need to go down 14.2 meters per second And when I connect the beginning to the end, I get my initial velocity vector. If I want to find the magnitude and velocity of this, the magnitude and angle of this vector, I can use Pythagorean theorem to find the magnitude. So this is the square root of Vx initial squared plus Vy initial squared, which are just the two sides of my triangle there, which leads to 21.9 meters per second. And if I want to find the angle, I can use an inverse tangent function. So here I can say that the angle that I'm interested in is this angle here, which I'll call theta, and I know that the tangent of theta equals 14.2, or I will write this as Vy initial divided by Vx initial, which is 14.2 meters per second divided by 16.7 meters per second. Theta is then the inverse tangent of these two angles, which I'll just write in terms of variables. And that comes out to 40.4 degrees. And because I'm below the x-axis, I'm going to call that negative 40.4. If you plug this into your calculator, you'll get a positive answer, but because I can see that my angle is below the positive x-axis, it's going to be negative 40.4 degrees. Now that we've found the magnitude and velocity of the initial velocity vector, the only thing that the problem asks us to find is the initial height of the object or the height of the cliff. And there's two options for doing this. We can actually use either my second or third equation in y to do this. I'm going to use the third equation just because I think it's a little more straightforward, but either works. We now know V final and V initial in the y direction, and we know the acceleration in the y direction. This should have a subscript y on it, which means the only thing that we don't know is my delta y. So if we move over and find a nice clean spot to do this on, we can say Vy final squared equals Vy initial squared plus 2ay delta y. My final y velocity is given by Vy final equals, and I've actually forgotten what it is now, so I'm going to go check here. I believe it is negative 28.9 meters per second. So here we have negative 28.9 meters per second. And my Vy initial is negative 14.2 meters per second. So I have 28.9, and I'm going to ignore units just for simplicity here. Okay, so there I have my final velocity equal my initial velocity plus my the acceleration due to gravity. Now, notice that I didn't bother to put the minus sign inside of the squares because it's just going to get squared and the minus sign is going to be removed anyway when we square it. Completing this, I get that delta y equals negative 32.3 meters. Now remembering that this is equal to y final minus y initial, that's our definition of delta y, and we know that my final y is 0, I get that y initial equals positive 32.3 meters, which was the height h of the cliff. So just as a review of where we have gone, we began by drawing our picture and writing down all of the information that we already knew about the problem. We then wrote down our kinematic equations, and we tried to find any equation that we could solve for a value that seemed useful. And we settled on finding Vx initial. The reason that worked was because we knew the change in x position and we knew the amount of time. So we were able to solve for velocity, which is what we did. We then used our knowledge about our position in the x direction and our velocity in the x direction to find our velocity in the y direction, our final velocity in the y direction, Vy final. And from there, once we knew Vy final, we were able to find Vy initial using our our first kinematic equation for y, Vy final equals Vy initial plus Ay times t. And once we knew Vy initial, everything kind of fell into place for us. We were able to find, we knew all of the initial velocities. We were able to find magnitude and direction on those. And we were then able to find our initial y position by knowing initial and final velocity and acceleration, which gave us all of the things that this problem was asking for. Because if we go back up to the original problem, it asks us to determine the initial launch height and initial velocity, magnitude and direction, which is exactly what we did.